Range sensors are devices that measure distance. They tell us how far an object is from the sensor. This information is incredibly useful in many modern technologies. Imagine self-driving cars that can avoid obstacles, robots that can navigate complex environments, and even smartphones that can measure distances. Range sensors make all of this possible. These sensors are like our eyes, but instead of seeing, they feel the distance to objects. They emit a signal, like sound or light, and then measure how long it takes for the signal to bounce back after hitting an object. This time delay directly relates to the distance between the sensor and the object. Range sensors are becoming increasingly common in our technology-driven world. Understanding how they work is essential for grasping the capabilities and limitations of various devices that rely on this technology. In the following sections, we will delve deeper into the different types of range sensors, their working principles, and their diverse applications. Range sensors operate based on the principle of time of flight, or TOF. To measure distance, they follow a simple three-step process. First, the sensor emits a signal, which could be a sound wave, ultrasonic, a beam of light, laser or infrared, or radio waves, radar. Then, this signal travels through the air until it encounters an object. Upon hitting the object, the signal is reflected back towards the sensor. Finally, the sensor detects the reflected signal and measures the time it took for the signal to travel to the object and return. Using the speed of the signal, for example, the speed of light or sound, the sensor calculates the distance to the object. This fundamental process allows range sensors to accurately determine distances to objects within their range. The accuracy and range of these sensors depend on factors such as the type of signal used, the sensitivity of the sensor, and environmental conditions. There are various types of range sensors, each utilizing different types of signals and offering unique advantages and disadvantages. Ultrasonic sensors emit sound waves and measure the time it takes for the echoes to return. They are commonly used in parking sensors and robotics due to their low cost and simplicity. Infrared sensors use infrared light to measure distance. They are often found in proximity detectors and touchless faucets due to their fast response time and low power consumption. Laser rangefinders employ laser beams to accurately measure distances over long ranges. They are commonly used in surveying, construction, and military applications. LiDAR, or light detection and ranging, uses laser pulses to create a three-dimensional map of the surrounding environment. LiDAR is crucial for self-driving cars, drones, and mapping applications. Each type of range sensor has its strengths and weaknesses, making them suitable for specific applications. Understanding these differences is essential for selecting the right sensor for a particular task. Range sensors are used in a wide range of applications, including the automotive industry. Collision avoidance systems, adaptive cruise control, parking assistance, and self-driving cars rely heavily on range sensors to detect obstacles and maintain safe distances. In robotics, robots use range sensors for navigation, obstacle avoidance, and object manipulation. These sensors enable robots to operate autonomously in complex environments. In consumer electronics, smartphones use range sensors for autofocus in cameras, gesture recognition, and augmented reality applications. In industrial automation, range sensors are crucial for process control, quality inspection, and automated guided vehicles in factories and warehouses. In healthcare, range sensors are used in medical imaging, patient monitoring, and assistive technologies for the visually impaired. These examples highlight the pervasive presence and significance of range sensors in our everyday lives. As technology continues to advance, the applications of range sensors are only expected to grow, further shaping the way we interact with the world around us.